Good morning, all of you. Welcome to C. J in the Rank Zone. I'm M. Satish, your chemistry lecturer. So we have already started thermodynamics. We have completed 5 lectures. Now this is lecture number 6. So in this lecture, we are going to discuss about spontaneity and entropy. Entropy and spontaneity. So which is very important topic. So so far we have completed up to thermochemistry. In thermochemistry, so first law of thermodynamics is over. Now we are going to see second law of thermodynamics in this class. I hope it is clear. So let us start the class now. So limitations of first law of thermodynamics. What are the limitations of first law of thermodynamics? Let us see now. So first law of thermodynamics gives no idea about the feasibility. It has only given about heat is constant, that law of conservation of energy. It is no idea about the feasibility or spontaneity of a given chemical reaction or a physical process. So in a physical process or chemical process, it does not discuss about anything about feasibility of the reaction or the process or spontaneity of the reaction or the process. So that's why, so for example, it does not place any restriction to on the direction of flow of heat. So it does not say whether heat flows from a hot body to a cold body or from a cold body to hot body. It only says that energy is conserved if such a transformation takes place. I hope it is clear. So first, these are the limitations of first law of thermodynamics. What are the limitations of first law of thermodynamics? It does not give any idea about feasibility or spontaneity of a given chemical reaction or a physical process. For example, it does not place any restriction on the direction of flow of heat. It does not say whether the heat flows from a body at high temperature. It shows only a body from hot body to a cold body or from cold body to hot body. No direction. And it only says that energy is conserved if such a transformation takes place. Only energy. It states about the energy only. Now we are going to discuss all these points in the second law of thermodynamics. Let us see now. According to the first law of thermodynamics, there is no restriction on the complete conversion of heat into an equivalent amount of work. However, heat engines with 100% efficiency, that is, those which can convert heat completely into work, are non existent. So, we do not have ideal machines that is converting of heat 100% of heat engines with 100% efficiency. Some amount of energy is being wasted. That is called dissipation of energy. What is it is called? Dissipation of energy. Dissipation of energy means the conversion of energy into useless form, from useful form to useless form. Dissipation of energy is not mentioned in first law of thermodynamics. Dissipation of energy. So there is no heat engine so far designed with 100% efficiency, because some amount of heat is being used up for running the engine. So that is 100% efficient engine is not. There is no ideal machine. We will call it as ideal machine. So in general, there is no ideal machine. So this led to the concept of discovery of spontaneity and feasibility. So let us see now. What is second law of thermodynamics? It is based upon, it is with the spontaneity or feasibility of chemical reactions and physical processes. So second law of thermodynamics deals with spontaneity or feasibility of chemical reactions and physical processes. It also deals with efficiency of heat engines. So what is spontaneity? Very important. Spontaneity is most important. Definitely they'll ask questions. So this entire chapter is very important. 100% you will get 2 or 3 questions for any competitive exam, entrance exams like JE Mains, JE Advanced, or NEET, or AIMS, etc. So a spontaneous process is defined as a process which has a natural tendency to occur in a particular direction, either on its own or after proper initiation under the given set of conditions. Very important. A spontaneous process is defined as a process which has a natural tendency to occur in a particular direction, either on its own or after proper initiation. So either the reaction or the process takes place on its own or proper initiation under the given set of conditions. For example, flow of heat from a hot body to a cold body, down the hill, flow of water. So flow of water from the hills, intermixing of gas in air, evaporation of water at room temperature. All these are the examples of spontaneous process. So it is a natural tendency or in a particular direction, natural tendency to occur in a particular direction. So for example, if you take flow of water down the hill, they'll come by their own. They'll come by their own. So that is called spontaneous process. And either on its own or after proper initiation under a given set of conditions. So intermixing of gases, evaporation of water at room temperature, all these are called spontaneous process. Spontaneous process is nothing but, in other words, it is a natural process which has a natural tendency to occur in a particular direction. So second law deals with spontaneity. So I hope it is what is spontaneous. It is a natural process which occurs in a particular direction either on its own or after proper initiation under the given set of conditions. What is non-spontaneous process? It is a process which cannot take place on its own but can take place with the help of external force. So non-spontaneous process means by the means of external force or external agency. Work has to be done to drive such processes. So for this we need work. For spontaneous process, work done is equal to zero. But for non-spontaneous, because spontaneous process means natural process, so work has to be done in to drive such processes, that is non-spontaneous process. Flow of water from a water reservoir to an overhead tank by the means of motor will send with the help of an electric motor. So this is nothing but what? It is a non-spontaneous process because it has to be initiated. Not only initiated, work has to be done. That is, electric motor should run. Then only the water from a water reservoir can go to a overhead storage tank, can go to a overhead storage tank. So movement of gas from a low pressure region to a high pressure region using a suction pump. So that is like, you can say, semi-permeable membrane, or you can say movement of gas from a low pressure region to a high pressure region using a suction pump. So this is called as non-spontaneous process, and non-spontaneous process cannot take place of its own. Very, very important. So these are different processes. By the use of external help, it can take place with the help of an external force or external agency. In this case, work has to be done to drive such processes. I hope it is clear what is spontaneous and what is non-spontaneous. Spontaneous is natural process which takes place on its own, whereas non-spontaneous means it is not natural process, but it will take place with the help of an external force. Now, criteria for spontaneity of a process. Most of the exothermic reactions are spontaneous. Most of the exothermic reactions are spontaneous. This is the first condition. Example, when methane is burnt in air, it forms carbon dioxide and water. Delta H of formation is minus 890.3 kilojoules per mole. So it is exothermic. And even formation of HCl gas from hydrogen and chlorine gas also, once the reaction starts, it takes place by itself. Hence, we may feel that for a spontaneous process, delta H must be negative. Very, very important. For a spontaneous process, delta H must be negative. So it should be exothermic. So most of the exothermic reactions are spontaneous, and for a spontaneous process, delta H must be negative. What is the second criteria? First criteria is delta H must be negative. Now let us see the next criteria. But certain endothermic processes and reactions are also spontaneous. Example, evaporation of water. Heat is absorbed by water from the room temperature so that it will melting of ice and decomposition of calcium carbonate. These are all endothermic processes. Thus, enthalpy factor alone cannot explain spontaneity. So, simply if you say delta H is negative for all spontaneous processes, is wrong. So, it is not only enthalpy factor alone cannot explain spontaneity of a process. To explain the spontaneous nature of endothermic process, a new function known as entropy was introduced. Very, very important. What is entropy? So, what are the two factors that decide spontaneous? That is delta H and delta S. That is change in entropy. Entropy is denoted by the symbol S. S is called entropy. S is called entropy, and delta S is called change in entropy. So, what is entropy? That also we discuss now. And this is delta S, that is change in entropy. So the enthalpy factor alone cannot explain spontaneity of a process, because in the previous slide what we have discussed, spontaneous, most of the spontaneous process reactions are exothermic, but some spontaneous reactions that will take place by its own, that is evaporation of water, we need not have to do any work. Melting of ice, simply if you keep ice in the outside, automatically to change into water. And the decomposition of calcium carbonate also decomposes to form calcium oxide and carbon dioxide. So for all these things, without doing any work also, we can give the change in the process. So that is nothing but all these are natural processes which requires no work is done. But these natural processes are endothermic in nature because some heat they will absorb. So that is called, these are also called as spontaneous processes, where we have endothermic processes. So spontaneous process can be endothermic or exothermic depending on the process. And that's why enthalpy factor alone cannot explain spontaneity of a process. To explain the spontaneous nature of endothermic processes, a new function known as entropy was introduced. It is denoted by the letter S. S is called entropy. Now we'll discuss what is entropy. Very, very important. So two factors are deciding spontaneity. First is enthalpy and next one is entropy. Entropy, yes, is a thermodynamic quantity which is a measure of degree of disorder, a measure of randomness or disorder. Randomness of a system is called entropy. Degree of disorder or randomness of a system. Very, very important. So entropy is the thermodynamic quantity which is a measure of the degree of disorder or randomness of a system. Greater the disorder, larger is the value of entropy. So greater the disorder, larger is the value of entropy. And it is a state function. Entropy is an extensive property, while molar entropy is an intensive property because it is confined to 1 mole of a substance only. So since it is confined to 1 mole of a substance, so it is an intensive property where it does not depend upon quantity of matter. And normally entropy is an extensive property, depends upon the quantity of matter. So it is a state function. It is a measure of unavailable energy of the system. And change in entropy, that is delta S, is equal to Q reversible by temperature, sorry. Q reversible by temperature, where Q reverse is the amount of heat absorbed by the system reversibly at constant temperature T. So Q by T, delta S is equal to Q by T. I hope it is clear. So this is called entropy. Entropy is nothing but measure of randomness or disorderness. So for example, sodium solid, by giving some sublimation energy, we are changing it to sodium gaseous atom. So in this case, entropy is maximum because solid means ordered arrangement, entropy. And in this case, entropy is less. Entropy is maximum. Why? Because gases means the molecules are not arranged in the order. So the molecules are very far away. So that's why we can say entropy of solids is less than entropy of liquids, is also less than entropy of gases, because in gases the entropy is maximum because the molecules are far from each other. In solids the entropy is minimum, it is less because the molecules are closely packed. As the molecules are closely packed in solids, they have less tendency to have entropy, whereas liquids they have moderate and gases they are very high. So entropy of gas molecules is high when compared to solids and liquid molecules. I hope it is clear what is entropy. It is nothing but the measure of randomness or degree of disorder of a system. So it is called entropy. I hope it is clear. So entropy. So what is entropy? In spontaneous endothermic processes, disorder of the system or entropy of the system increases. For example, when water evaporates into its vapor, it moves from an ordered state to a more disordered state. As I told you, water is liquid form, so the molecules are a little bit closely packed. Whereas when it changes into vapor, the molecules move far away from each other, so it is nothing but disordered state. Similarly, in a chemical reaction, if the number of moles of gaseous products is more than number of moles of gaseous reactants, so that is NP is greater than NR, number of moles of gaseous products is greater than number of moles of gaseous reactants. So then we can say disorder as well as entropy increases. So by this you can say if delta N is negative, entropy increases. Entropy increases. Thus, for endothermic reactions, increase in entropy or disorder is the driving force for spontaneity. So it is for endothermic reactions only. And increase in entropy or disorder is the driving force for spontaneity. It's the driving force for spontaneity. So this entropy topic is very, very important. If delta N is negative for a given chemical reaction, what is delta N? Number of parts minus number of reactants. Number of moles of gaseous parts minus number of moles of gaseous reactants. So if number of moles of gaseous parts is greater than number of moles of gaseous reactants, what happens to delta N? Delta N becomes positive. If delta N is equal to positive, entropy increases. For example, if we take for delta N is number of moles of product, sorry. So it should be positive. Delta N should be positive, then entropy increases. In the previous, I have told negative, it is wrong. So if delta n is equal to positive for a chemical reaction, entropy increases. If delta n is negative, entropy decreases. So in a chemical reaction, if the number of moles of gaseous products is more than that of gaseous reactants, disorder as well as entropy increases. I hope it is clear. So please note down these changes. So this is your class notes. Every slide you make a notes so that it will be easy for you to understand clearly. Only by listening you cannot understand. By doing only, that is by copying the notes and doing the problems, then only you can understand easily the topic. So please note down the given slides as your classwork notes. Next, entropy of solids, liquids, and gases. As I told you, more the disorder, more is the entropy of the system. So entropy of a substance in three physical states is in the order entropy of gas is greater than entropy of liquids, greater than entropy of solids. Why? Because in gas, the molecules are far apart, so the randomness is more. So in the gas, what happens? The molecules move randomly in all the directions. As the molecules move randomly in all the directions, they are not very close to each other. So entropy is maximum, that is disorderness is maximum. Similarly, liquid, it is less when compared to gas, and when compared to solid, it is more because liquids also can flow, and solids, the entropy is minimum, negligible, because in solid, the molecules are very closely packed. So the orderedness is more than disorderness. So that's why this is the order. So this is also very important order. They'll ask in the examinations, which of the following is true regarding entropy of solid, liquid, and gas. So units of entropy, calories per degree, because entropy S is equal to Q reversible, that is heat by temperature. Heat is measured in calories and temperature is measured in degree C or Kelvin. So calories per degree C per mole or joules per Kelvin per mole. Joules per Kelvin per mole also we can write. So these are the units of entropy. Joules per Kelvin per mole. Units is also important. So I hope it is clear. Next. So for the spontaneity of the reaction, two conditions are required. What is that? First is enthalpy change. Second is entropy change. Entropy changes in phase transitions. During a phase change, for example, at the boiling point of a liquid, suppose you take water, it changes to vapor, that is at 100 degrees C. So the boiling point of liquid, heat is observed at constant temperature, and the two phases may be considered to be at equilibrium with each other. So the two phases will be considered to be at equilibrium with each other. Hence, the following equations may be used to calculate entropy of phase changes. So, entropy of fusion is equal to entropy heat of fusion by melting point, that is Q by T. So, change in entropy of fusion is equal to, that is, entropy of fusion is how much? So, entropy of fusion, enthalpy of fusion by melting point. Entropy, change in enthalpy of fusion by melting point. So, these formulas are very important, simple formulas. Easily you can understand this. So, S is equal to Q by T. So from this standard, we can get delta S. That is delta S is equal to delta Q by P. Delta Q is nothing but delta H by T. Where is T? T is called melting point because here the phase transition, that is fusion. Fusion. Why? Because when a solid changes to liquid, it is called fusion and it is called melting point. So for example, water, what is the melting point of water? Ice, it is equal to 0 degrees C or 273 kelvins, and we'll take consideration kelvins only. I hope it is clear. So entropy of fusion is equal to delta S of fusion is equal to delta H of fusion by melting point. So this is the entropy changes during phase transmission continuation. Similarly, entropy of vaporization also. Entropy of vaporization delta S is equal to delta H of vaporization by boiling point. So entropy of sublimation is equal to delta H of sublimation by sublimation temperature. Sublimation temperature. So here M should be written. So it is called sublimation temperature. So I hope it is clear. To find entropy of a reaction, delta S is equal to delta H by T. So normal reaction, delta S is equal to delta H by T. That is heat of enthalpy change of the reaction by temperature. I hope it is clear. This is called entropy of a reaction. Heat of formation of reaction by temperature. So this is delta HF, heat of formation of reaction. So in this way, we will calculate entropy. Let us see now more questions about entropy. Entropy is a criteria for spontaneous process. How? During a process, the entropy of the system as well as that of surrounding changes. any process you take, physical or chemical process, the entropy of the system as well as that of the surroundings changes. A given process to be spontaneous, the total entropy change must be greater than zero. If delta S is positive, the total entropy change is greater than zero. Then only we can say the reaction is spontaneous. So this is a condition. So for delta S total is equal to delta S of universe is equal to system plus surroundings greater than should be zero. So delta S total is that is total change in entropy is equal to entropy change of the universe, which is also equal to entropy change of system plus entropy change of surroundings in physical processes. Even chemical process also you'll get the same thing, but you'll have different. What is the different? Entropy of a reaction is equal to entropy of reactants plus entropy of products. So if delta S total is less than zero, the process is non-spontaneous. And if delta S total is equal to zero, then the process is at equilibrium. All these three conditions are very, very important. So please note it down. So for the process to be spontaneous, what are the two factors, important factors? For the process to be spontaneous, here I'm writing, please note it down in your notes. For the process, either it is physical process or chemical process, to be spontaneous, two important conditions. What is that? First one, delta H is negative, that is less than zero, that is change in enthalpy should be negative, and delta S should be greater than zero, that is positive. So this is very, very important point. So for the process to be spontaneous, delta H should be less than zero and delta S should be greater than zero. What is delta S? Change in entropy. So for a given process to be spontaneous, total entropy change must be greater than zero. And this total entropy change is equal to entropy change of universe, and it is also equal to entropy change of system plus entropy change of surroundings. And these two should be greater than zero. And if delta S, that is total entropy change, is less than zero, the process is non-spontaneous. And if total delta S is equal entropy change is zero, then the process is at equilibrium. For all equilibrium reactions, delta S total is equal to zero. I hope it is clear. Very, very important, these 3 points. Please note it down in your classwork because these conditions only they'll ask in the examination. Let us move on to next topic. Entropy criteria for spontaneous processes. The entropy of the surroundings may be calculated from the equation delta S of surrounding is equal to delta H of system by T. That is minus delta H. Minus delta H of the system by T. So for example, for the reaction H2 plus Cl2 gives us 2HCl. Delta H of the reaction is minus 184.6 kilojoules, means this is given to surroundings during the formation of this reaction. So that delta H of the system is minus 184.6 in 10 to the power of 3 joules. Because kilojoules is given, you have to convert them into joules by 298 because at room temperature. So it is 619.5 joules per Kelvin. This is called delta S of surroundings. I hope it is clear. So in this way you have to calculate. Next. Now example one, very, very important. Now we are going to discuss based on entropy changes questions. Questions based on entropy changes. So these questions are most important. Predict the sign of entropy change in each of the following, whether it is positive or liquid. Liquid crystallizes into a solid. So liquid changes into solid. So randomness decreases or increases. Randomness decreases because in liquid, randomness S is more and randomness is more, and in solid, randomness is less. S is less in solid because solid means ordered management. So from disordered to ordered, from disordered liquid to solid. So from disordered to order it is changing. So entropy should be negative. Entropy change should be negative. That's why this is non-spontaneous. Why non-spontaneous? Because for liquid change to solid, we have to give out, we have to cool it. Means we have to decrease the temperature. So work is done in the system. So delta S is negative. Next, temperature of crystalline solid is raised from 0 kelvins to 115 kelvins. Crystalline solid. When a solid is raised from 0 kelvins to 115 kelvins, so automatically it may convert into liquid or some disturbance should be taking place. In this case, delta S is positive. Why it is positive? Because from 0 kelvins to 115 kelvins, automatically the molecules in the solid, the crystalline solid, the molecules will move apart from each other by observing this much of heat energy, that is temperature. Next, sodium bicarbonate solid changes to sodium carbonate solid, carbon dioxide gas, and H2O gas. So from one solid we are getting into, so that is total order management. Sodium bicarbonate is changing into sodium carbonate, carbon dioxide, and water molecules. So these two are gases. So automatically entropy is maximum. So change in entropy is equal to positive sign of change in entropy. And hydrogen gas order management to hydrogen atoms. Here also delta S because they are ordered to disordered, because gas molecule and this is atom, so it is order to disorder. So in this case also delta H is positive. So I hope it is clear. So they'll ask this type of sign changes in the examination. So let us check the answers right now. So negative, first one is negative, as we got delta H is negative. Second one is positive because solid is raised from 0 kelvins to 115 kelvins. Entropy increases with the increase of temperature. So 0 kelvins to 115 kelvins. So automatically the crystalline solid will not be that much crystal. It may be loose or it may change to liquid also depending on its melting point. So definitely it is positive. Third case, solid changes to gas. You can see here it is ordered management. That is sodium bicarbonate solid. It's changing to sodium carbonate solid, carbon dioxide gas, and water. So one molecule is changing to three different molecules. So automatically the randomness increases. So entropy is positive. Next, molecule change into atoms. That is also delta S is positive. So all these four cases are very important. These are nothing but four different questions. I hope it is clear. It's very, very important. So first is negative, second is positive, third is positive, fourth is positive. With the reasoning also I have explained you. So in this way you can find the predict the sign of entropy change. So entropy change will be positive if the process changes from order to disorder. Ordered manner to disordered manner, disordered manner. We can say delta S is positive. If disorder changes to order, disorder changes to order, that is gas changing to liquid or gas changing to solid, that is ordered manner. Entropy change in entropy is negative. So in the first case, entropy is negative because a liquid crystallizes into a solid. Liquid is molecules are loosely packed, whereas solids molecules are closely packed. So entropy of liquid is greater than solid. So in this case, delta S is negative. I hope it is clear. So all these processes are very, very important. So this question is most important. Like these questions you'll find for entrance examinations. They'll ask. I hope it is clear. Next. So with this next question, delta H of vaporization, that is entropy of vaporization is given. Change in entropy of vaporization of acetone is 93 joules per Kelvin per mole. If boiling point of acetone is 56 degrees C, calculate the heat required for the vaporization of 1 gram of acetone. 1 gram of acetone. Here they are given 1 gram of acetone. So first we'll find out for 1 mole of acetone. Heat of vapor, entropy of vaporization of acetone is 93 joules per Kelvin per mole, and boiling point of acetone is 56 degrees C. So first we'll find heat of vaporization for 1 mole of acetone. Then we can find for 1 gram of acetone. So let us see now. Since already we know delta S is equal to delta H by T. That is heat of vaporization by T. We don't know the heat of vaporization because heat of entropy of vaporization is given. By this you can say delta H of vaporization is equal to delta H of vaporization is equal to delta S by T, where T is called absolute temperature. We have changed this to 56 degrees T. So T is equal to 56 plus 273. So 273 plus 56 is how much? That is here it is 56 plus 273. We can easily change into kelvins. So that is equal to 56 plus 273. Just doing it is equal to 329. So 329 kelvins. So and this is in joules per Kelvin per mole. If they have given in kilojoules, we have to convert them into joules because it is joules per Kelvin per mole. So this delta H implies delta H of vaporization is equal to Delta H of vaporization is equal to, it is 93 into 329. Sorry, this is into T. Just wrapping it. Confusion. It's not confusion, only writing part I have done mistake. Delta S into 2 because T will go this side. So it is 93 into 329. So which is equal to 30,587 joules per mole. Very important, joules per mole. So acetone formula is already we know C2H2. C2H2 means it is nothing but carbon 12 2s are 24 plus hydrogen 2. So it was total is 26 grams. So for 26 grams of acetone, acetone formula is C2H2. Heat of vaporization is 30,597 joules per mole. Then for 1 gram, it is how much? So simply we can take, because they are asking heat required for the vaporization of 1 gram of acetone. So 30,587 divided by 26. 30,597 divided by 26 grams. You'll get it as 1176.8. So implies heat of vaporization is equal to 30,597 divided by 26 is equal to 1176.2. I'm writing it here, the next line. So it is equal to 1176.8 joules per mole. So answer, this is the answer. If they are given the answer in kilojoules, it is 1.1768, 1.1768 kilojoules or 1.1768 kilojoules. So I hope it is clear. Let us check the answer now. So 527.53, it is wrong because by 2 they have given, because C2H2 is acetone. Oh, sorry, it is acetone. No, I have taken acetylene. So please change it. Process is same, but this is not C2H2. This should be acetone formula is what? Acetone formula CH3COCH3. So the molecular weight will change. So 12 plus 3 plus 12 plus 16 plus 12 plus 3 is equal to 12. Actually, if it is acetylene, this is the answer, but this is not acetylene, this is acetone. So you can take two problems at least. 12 plus 15 plus 12, 27, 27 plus 3, 30, 30 plus 16, 46, 58. So for 58, how much? So this should be 1 gram, it is how much? For 58 grams, this should be how much? 58 grams. So please note it down, because 58 grams we have to take. 58 grams of CH3, CH2. I'm changing it, please note it down. 58 grams of CH3COCH. This is the formula of acetone. CH3COCH3 is the formula of acetone. So 1 gram of acetone is how much? So it should be 58 divided by 58. I'm just wrapping it. Please note it down. I have taken, I thought of it is acetylene, so it is acetone. So sometimes you'll get confusion here. So by 58. So 30,597 by 58. Let us calculate now. 30,597 divided by 58 is equal to 527.53 joules. So it is equal to 527.53. So you got it is less than 1000. So it is 527.53. So answer is this. I hope it is clear. This is C2H2. I'm wrapping it. This is not C2H2, acetone. Actually, I thought it is acetylene, so that's why I have done like that. But this is acetone. So I hope it is clear. Clear. So delta H of vaporization of acetone is given 93 joules per Kelvin per mole. If boiling point of acetone is 56 degrees C, so that is converted into 329 kelvins. Calculate the heat required for the vaporization of 1 gram of acetone. 1 gram of acetone. They have not asked for 1 mole. 1 mole means this is answer, but they have asked for 1 gram. So 58 grams is this much. So 1 gram is how much? Using stoichiometric equation. So delta H of vaporization is equal to 30,597 by 58. So it should be equal to 527.53 joules. I hope it is clear. So next. Example 3. Calculate the entropy change involved in the following processes. Entropy change. They are asking delta S. Fusion of 1 mole of ice at 0 degrees C. 1 mole of ice at 0 degrees C. 1 mole directly they have given water. And latent heat of fusion of ice is equal to 334.72 joules per kilograms. And vaporization of 1 mole of water at 373 kelvins. The latent heat of vaporization of water is 2.52 kilojoules per gram. Kilojoules, they have given kilojoules. You have to change into joules. So, what is the formula for delta S entropy change? Delta S is equal to, that is entropy change of fusion of ice is equal to enthalpy change of fusion of ice by change in temperature. That is temperature. Temperature is 273 Kelvin. So simply we can take 1 mole directly they have given. So latent diffusion of ice is given 334.72 by 273, which is equal to, so 334.72 divided by 273. So change in entropy is 1.22, approximately 1.22. So let us see first case. So it is 22.06, and latent heat of here they have given latent heat of fusion of ice, that is 334.72. 1 mole of ice. 1 mole of ice means here 1 mole of water contains 18 grams. So 18 into 18. So if you take 1.22 into 18, so you'll get 22.06. So this is for one water molecule, but they have given 1 mole of ice. So 1 mole of ice means 18 grams, because 1 mole of ice contains 18 grams. 1 mole of ice contains 18 grams. So delta S is equal to 18 into 1.22. That is equal to 22.06. Similarly, 1 mole of water at 373 kelvins. So delta S is equal to delta H by T. Delta H by T means delta latent heat into number of moles. Simply, you can take latent heat of vaporization of water is 2.52. That is 2.52 into 1000, 10 to the power of 3 into 18, because 1 mole of water by 373 kelvins. So if we take this into consideration, so let us take into consideration second case. This is second problem. So delta S is equal to delta H by T, 2.5 to 2.52. That is 2.52 into 1000 into 18 is equal to 45,360 divided by 373. You got it as 121.6. So you'll get 121.6 after calculating this. So here itself we can take 18. Previous case I have taken separately to understand. So here itself we can take into 18. I hope it is clear. So 121.6 joules per Kelvin. Because this is in kilojoules, we have to change it into 10 to the power of 3, 2.5 to 10 to the power of 3. So this is first problem and this is second problem. I hope it is clear. Both are easy. So simple formula application. Let us move on to second. So some more questions based on entropy. Now we are going to discuss. So since we have discussed only 3 questions now, let us take question number 4. Very, very important topic this is. That's why I want to discuss more number of questions. So question number 4, let us discuss now. Question number 4. So in which of the following cases, these questions you will not get again in PPT, so that's why please note it down. In which of the following cases, because these additional questions I want to discuss. In which of the following cases the reaction is spontaneous at all temperatures? The reaction or the process is spontaneous at all temperatures. Very, very important. At all temperatures. So, at all temperatures. Option A, delta H is greater than 0 and delta S, that is change in entropy, is greater than 0. Option B, delta H is less than 0 and delta S is greater than 0. That is change in entropy is positive. Option C, delta H is less than 0, comma, delta S is less than 0. And option D, delta H is greater than 0, comma, delta S is less than 0. So, what are the two conditions for the spontaneity of a reaction? For the spontaneity, that is spontaneous reactions, the first condition is delta H can be negative or positive, but most of the reactions delta H is 0. That's why for benefit of doubt, delta H should be less than 0 and delta S should be positive. Then only we can say the reaction is spontaneous. So answer is second option. I hope it is clear. Next question. Question number 5. Simple questions we are discussing now. When potassium chloride is dissolved in water, when potassium chloride solid, usually potassium chloride exists as solid, is dissolved in water, is dissolved in water. This is the condition they are given. Option A, entropy increases. Entropy increases. Option B, entropy decreases. Option C, entropy increases and then decreases. First entropy increases and then decreases. In simple statement based questions also they'll ask. And option D, free energy increases. This free energy we'll discuss in the next session. So what is free energy? The energy associated with the system is called free energy. It is denoted by the letter G. So free energy increases. So out of these four conditions, simply we can say when potassium chloride dissolved in water, so solid potassium chloride, when it dissolves in water, it forms potassium ions as well as chlorine ions, aqueous. So because they change into ions, because it is an ionic compound. So automatically its molecule changes into ions. So randomness increases. So entropy increases. So delta S is positive. So delta S is positive means entropy increases. So answer is first option. Very clear. So I hope like these questions you'll get in the examinations. So it is very clear. Next question. Question number 6. Which are the following reactions? Sorry, for the process. CO2 gas, sorry, CO2 solid, CO2 solid, change to CO2 gas. First option, both delta H, very, very important. You have to think and write. Both delta H and delta S are positive. that is greater than 0. Second option, delta H is negative, comma, delta S is positive. Third option, delta H is positive, comma, delta S is negative. Fourth option, delta H negative and delta S are positive. So both delta H and delta S are negative. So which is the right answer? Now we have to check. Generally, if you see solid changes to gas, it means entropy increase. So delta S should be, because from ordered management to disordered management. Because solid, the molecules are closely packed, and gas, the molecules are loosely packed. They are far from each other. So entropy of solid is less than entropy of gas. So it is delta S is positive. Clearly we can see. Next, coming to delta H, enthalpy. So for the solid to change into gas, we require heat. So that is endothermic process, because a solid can be changed into gas only by giving heat. So by giving heat means endothermic process. So delta H is also positive. So by this we can say delta S is positive, delta H is also positive. Delta S is positive, delta H is also positive for this process especially. So answer is first option. I hope it is clear. So this is a first option answer. So this type of questions are important for exams, entrance exams. Now question number 7. which are the following in which of the following process entropy increases? In which of the following process? In which of the following process entropy increases? Entropy increases. Option. So they are given 4 conditions. A, rusting of iron. They are given physical process. So in this also you have to be careful. Option B, vaporization of camphor. Vaporization of camphor. Second process. They are given 4 different processes and they are giving 4 options. And next process is crystallization of sugar syrup. Crystallization of sugar syrup. And fourth one, atomization of dihydrogen. Atomization of dihydrogen. These are the 4 different processes they are given. Now options. First option A and B. Second option B and C. Third option B and D. And fourth option only D. So let us check the answer. No? Rusting of iron. Rusting of iron means here iron gets rusted. So iron converts into iron oxide, because rusting of iron means what? It forms iron oxide with X moles of water. So both the cases it is solid only. So entropy is decreasing because it is more ordered, from disordered to more ordered form. So it is entropy is increasing. So rusting of iron is not entropy is decreasing because ordered form only. It is more ordered form it is forming. So first case it is not right answer. Vaporization of camphor. When camphor, liquid camphor is burnt, it changes to vapor. So automatically, so it's solid. Solid changes to directly gas. So in this case, entropy, because in this case, solid changes to gas because camphor is in solid form. When you burn, it changes to gas. That's why solid changes to gas. So automatically vaporization of camphor is entropy is increasing. So answer is B, as well as next crystallization of sugar syrup. So here sugar liquid is converted into solid. So in this case also liquid is converted into solid. So we cannot say this is entropy decreases in this case. And atomization of dihydrogen means hydrogen molecule change into hydrogen molecule atoms. So hydrogen molecule change into 2H. So this is also entropy increases. So answer is B and D. So answer is what? B and D. So in both these cases, we can see entropy increases. So so entropy is increasing. So I hope it is clear. And in this first and third case, entropy is decreasing. So please note down this type of questions you will get in the examination. Next question. Question number 8. Question number 8. So which are the following reaction? They'll give like these questions also important for entrance exam. Which of the following reactions? You have to see carefully the reaction. Which of the following reactions is is associated with the increase in entropy? Means randomness should increase. Increase in entropy. Increase in entropy. So first option, what they have given, nitrogen gas combined with 3 moles of hydrogen gas to form 2 moles of ammonia gas. Second option, hydrogen gas combines with 1 mole of oxygen gas to form 2 moles of water gas, liquid it is. Third case, hydrogen gas combines with iodine gas to form 2 hydrogen iodide gas. And fourth option is nothing but carbon in the form of graphite plus oxygen water. It forms carbon monoxide plus hydrogen gas. Carbon monoxide gas plus hydrogen gas. So together it is called as water gas. So in which case randomness is more? So first case, if you take nitrogen gas molecule, hydrogen gas molecule, these two individually they have more randomness, but when combined together to form ammonia, the randomness decreases. So in this case, entropy is decreasing. In this case also, they are forming from disorder to order. So in this case also entropy decreases. And third case also same. So in this case entropy decreases. Fourth case, if you see carbon in the form of graphite, that is solid, gas changing into gas and gas. So carbon individual element and water change to carbon monoxide and H2. So in this case delta S is increasing. So increasing entropy is more in this case. So answer is D. Answer is fourth option. I hope it is clear. This type of questions are very important. So next question, we'll proceed to next question now. Please note down these questions in your classwork. Question number 9. So when I'm writing the question, you also write down the question and write the options and think about the answer clearly. Now let us do some numericals based on this. Question number 9 now. When? This is previous advanced question. Simple question. But when enthalpy and entropy. When enthalpy and entropy change, for a chemical reaction are for a chemical reaction are minus 2.5 into 10 to the power of 3 calories and 7.4 calories degree calories per degree respectively. Predict the reaction at 298 Kelvin Cs. 298 Kelvin Cs. First option, spontaneous. Second option, reversible. Third option, irreversible. And fourth option, non-spontaneous. So whether it is spontaneous or non-spontaneous, we have to discuss now. That's the only question now. So let us see the answer. Let us discuss now. So, so it is spontaneous or non-spontaneous, we have to discuss. So the enthalpy change, entropy change for chemical reaction are minus 2.5 in 10 to the power of 3 calories and 7.4 calories per degree respectively. So since the entropy value is directly given at 7.4, so whether the reaction is at 298 calories is spontaneous or non-spontaneous, we have to discuss. So already we know delta S of the reaction is equal to delta H minus delta H by T, minus delta H by T for a chemical reaction. So minus delta H is minus delta H is how much it is, minus 2.5 10 to the power of 3, minus of minus 2.5 into 10 to the power of 3 divided by temperature is 298 kelvins. So don't take this value 7.4. This is given for that reaction. Now at this temperature, whether it is spontaneous or not, we have to discuss. So 298 kelvins. So it is equal to, that is 2500 by 298. So it is plus 2500 by 298. So anyway, it is positive 2500 divided by 298. So it is positive and greater than 0. It is equal to 8.3 because minus of minus becomes plus. So 8.3 joules, sorry, calories per degree is the answer. Since delta S is equal to 8.3, delta S is positive, we can say the reaction is spontaneous. The answer is first option. The reaction is spontaneous. I hope it is clear. So these type of questions are important. So they have given this value for the general temperature, but they have not mentioned the temperature at this case. So don't take this value. They are, now we have to predict the reaction at 298 kelvins. At 298 kelvins, if you take into consideration, since delta H is equal to minus delta H of T, that is minus heat of vaporization by T, so minus of minus 2.5, that is equal to plus 2.5 into 10 to the power of 3, that is 2500 by 298, we got it as 8.3 calories per degree. So delta S is positive in this case. As delta S is positive, it is spontaneous. As delta S is positive, it is spontaneous. So answer is what? Spontaneous. If delta S is negative, non-spontaneous. If delta S is equal to 0, then it can be reversible. We cannot say reversible. We'll say delta S is 0. It is at equilibrium. So we know the conditions. So based on that condition, this question has come. I hope it is clear. Now question number 10. So all the different models I'm doing. So please note it down. Next, if delta H of vaporization of pure water, if delta H of vaporization of pure water at 100 degrees C, because already we know water boiling point is 100 degrees C, is 40.627 kilojoules per mole. Kilojoules per mole. Then the value of delta S of vaporization is, then delta S of vaporization is. So option 1 is straight question. 108.91 kilojoules per mole. Option 2, 108.91 joules per mole. So units are also very important. Joules per Kelvin per mole, sorry. Per Kelvin. Joules per Kelvin per mole. Next, option C is equal to 606.27. 606.27 kilojoules, sorry, joules per Kelvin per mole. Joules per Kelvin per mole. And option D, 808.27. 808.27 joules per Kelvin per mole. So these are the four options. Let us take into consideration now. Delta S, change in entropy, is equal to delta H of vaporization. Delta S of vaporization is equal to delta H of vaporization by temperature. So temperature is 100 degrees C. We have to consider into absolute temperature, that is 373 kelvins, because 100 degrees C is equal to 273 plus 100. So that is equal to 40.627 kilojoules. Whenever they are given kilojoules, we have to convert them into joules into 10 to the power of 3 divided by 373 kelvins. So it is equal to 40,627 divided by 373, which is equal to, let us calculate. So 40,627 divided by 373. So answer is 108.91. So it is equal to 108.91. Very, very important. It is joules per Kelvin per mole. So they have given 108.91 in two options, first and second option. But in the first option, it is kilojoules, second option is joules. So answer is B. Answer is what? Second option, that is 108.91. Whenever they are given kilojoules in heat, we have to change them into joules, because joules per Kelvin per mole is a unit of entropy. I hope it is clear. So 108.91 joules per Kelvin per mole. Next question. Let us take into next question. After that, we'll end the session. So last question in this session. So 10 questions we have done already. Last question we'll discuss now. The enthalpy and entropy change. The enthalpy and entropy change. The enthalpy and entropy change for the reaction bromine liquid plus chlorine gas to form 2BrCl gas are respectively they are given the values 30 kilojoules per mole. Per mole is given, so no need to give any attention. 30 kilojoules per mole and 105 joules per mole per Kelvin. 105 joules per mole per Kelvin, respectively. So respectively already have written. So please see this question clearly. Now, the temperature at which the reaction will be in equilibrium. The temperature, yes, writing it clearly. Oh, it has gone. So question number 11. Again, I'm writing. Please see it. Anyway, the place is not sufficient. Next question. So the enthalpy and entropy change. The enthalpy and entropy change. This question is most important. That's why I want to discuss now. Enthalpy and entropy change. for the reaction. For the reaction, Br2 liquid plus Cl2 gas converted into 2 moles of bromine chloride, that is liquid, gas, drops of gas only, are 30 kilojoules per mole, that is enthalpy change, and 105 joules per mole per Kelvin, joules per mole per Kelvin, that is entropy change, respectively. Now, what is the question? The temperature at which the temperature at which the temperature at which the reaction will be in equilibrium. The reaction will be in equilibrium is option A, 300 kelvins, option B, 285.7 kelvins, option C, 273 kelvins, and option D, 450 kelvins. So these are the 4 options we have. Very, very important options. So now based on this, how to calculate the enthalpy change? Let us see now. So this type question is very, very important. So for this, we should know delta G also. But still, if you can take delta S, if delta S is equal to 0, the reaction is at equilibrium. Reaction is at equilibrium. Reaction is at equilibrium. So we can say delta G is equal to delta H minus T delta S. If T into this equation, next we are going to discuss. So please note down. So if delta G is equal to 0. So if delta T delta S is greater than, if T delta S is greater than, is less than delta H, the reaction is at equilibrium. So multiply T delta S. So answer, you will take it as question number 7, answer 50. So it is second option. So 285.7 kelvins. So how to get it? Let us see now. Let us see now. As I told you. So 285.7 kelvins into 105. 285.7 into 105. If you take into consideration 285.7 into 105 is equal to 27,163 joules. So this is less than 30 kilojoules. So if delta S into T is less than, delta S into T is less than delta H, we can say less than delta H, we can say the reaction is at equilibrium. So if you take into others into consideration, this should be more than 30 kilojoules. This should be also more than, and 450 kelvin. So delta S into T should be almost equal to delta H. So delta S less than or equal to. So we can say this is the answer. I hope it is clear. More about this question we'll discuss later. So with this, I'm stopping this session. Very, very important session. All the models what we have done is very important for entrance examination. So please work out more number of questions from this. I hope it is clear. Thank you all.